Okay, so today is a big day because this is the day that your first big milestone is due, right? And I hope there are lots of questions because I had intended on spending as much time as you would like answering questions about the assignment. So here in figure 7.53, we have the finite state machine that you're supposed to implement. Okay, and I think I'll just open it up to questions. Yeah, the code, how to do this, how to implement this figure 7.53. Yeah, I assume, I've been giving you plenty of warning. I assume that everyone has started working on it. Has anybody, or let me ask you this, has anybody finished it? Oh, a number of you have. Oh, excellent. All right. Well, for those of you who have, you have any questions? Or if you haven't, do you have any, yeah, question? Oh yeah, all those, yeah, I expect that what you would do is you would, all that previous code that you've done that's relevant, you can copy and paste that into this. Yeah. Was that your question or no?
Yeah, pretty much, like several.
Oh yes, absolutely, yeah, yes. So, but actually, all right, that brings up a good point that I wanted to emphasize. So, first of all, in terms of shaping your code, I insist, here if we go back to here in figure 7.36, figure 7.36 should be identical. Okay, so that should not change at all. All right, so because we have a while, because we, remember, let's review that. While inBuffer.input remains, that while executes once per what? Once per line of input. And then the do executes one per what? Token. And then when we went back up to here to class tokenizer and we had get token, this do executes one per what? Yeah, you're right. It advances the input once, so it's one per what? One per character in the input stream. Right. Well, yeah, but then it should back up. But so now, and here, I don't know if you remember reading this in the description of the problem in the book, but notice that this next char gets b.advance input. That is the only place that should occur. Do not duplicate that anywhere else in your code. So what I'm saying is the control, those loops, those nested loops in action performed, and this do loop, those are you are forbidden to have any other loops. It needs to conform exactly to this format. Is everybody with me on this? So if some of you guys who got yours to work with some extra loops in there, that's not good. Go back and take those out. So are you with me on this? So because this design takes care of leading spaces, intermediate spaces, trailing spaces at the end of the line, et cetera, et cetera. Yeah. And that's a very good question. So the question is, when do you check for integer or hexadecimal overflow? And the answer is, to do it bulletproof, you have to do it after each, you have to do it in the finite state machine after each multiplication by 10 or by 16. Because if you don't, it's possible that it could cycle all the way through and cycle through again and get back to be in range and be incorrect. Do you understand what we're saying here? Do you remember when we did that example with how the default is to not check for overflow in C? Do you remember that example? Yeah. Tell me that you remembered that example that we did in C when we started like two or three numbers below the maximum integer value, and we added 1 to the integer, and then it flipped over, and then it went from the highest positive value, and it added 1 to that, and that changed it from 0, 1, 1, 1, 1, 1, 1, 1, 1, to 1, 0, 0, 0, 0, 0, which was the negative value with the largest magnitude. Do you see what I'm saying? But the thing of it is that now think about that with your question here. With the question that you have here. Checking for the overflow, if you check for the overflow once at the end, user could have put a long string of digits in there, and it could have overflowed, and then overflowed again, and then got back to be in range. You see what I'm saying? And then it would look like it was in range, but it would be the incorrect value. So remote, But to be bulletproof, you need to check it from within, inside the finite state machine, and make a with each operation, and then if it is out of range, then make that be the invalid token, because it's out of, yeah. So you might need to go back and change that. I don't know. Okay, so yeah. Oh, and then actually, I don't know that I specifically answered your other question, but yes, you will need you might need other local values, other local variables that are local values to collect the stuff.
Yeah, because you could put like into the.
Yeah. Oh, I see what you're saying. Yeah, you could reuse the string buffer, or you could have a separate string buffer for the identifiers for the addressing modes, and a separate one. And for documentation purposes, you take a little bit more memory, but for documentation purposes, that might be nice. Yeah. Also, you guys, do you know how to format your Java programs in NetBeans? You need to always, there's a command in there on NetBeans to format your source code. Always do that before you hand it in. And also, that's a good thing for checking to see if you have a logic error because of incorrect nesting. If you indent incorrectly, the indentation can throw you off. And if you format, that's a good tool for checking if your logic is correct in terms of nested if statements and nested loops and so on. Does somebody have NetBeans open there? What's the command? Go under. Oh, there's a command. There's a keyboard shortcut. Or what's the command up at the top? Source, and then what? Source format. Yeah. Yeah. So always do that. Same way as you should always do. What's the one in assembly language? Format from listing. Yeah. So always do that. And yeah, these are good questions. Yeah. Question? Oh, okay. What's the phrase? Enum. We have a thing in there called public enum state. Like that? Yeah. Okay. Good question.
Does that go in the tokenized?
Oh, no. This is in a file all by itself. The enumerated, because there's more to this, right? It has the values of the state. See here, let's look. Here in figure 7.35, you see where it says public enum lex state, and ls start, ls ident, ls sign, ls integer, ls stop. Okay, that code is all in a separate file because all by itself. All right? And that's how you set up the states for the finite state machine. And the way, are you with me? So that needs to be in a file all by itself.
Like, would it be called like lex state or what?
Yes, it would be, the name of the file would be lex state because that's the name of the class. Right. Are you with me? See here, actually, let's go back. Let me demo that. Let's do a demo. Okay, so here's our demo of, to answer your question. See here in figure 7.34, so you should have this. And then all of your new classes should be in the same package, right? Actually, we haven't explained that yet, so I'll explain that in a minute. And so under this package, fig 0734, you see here we have a state. Here we have lexstate.java, and if we see what's in lexstate.java, here's the code in lexstate.java. So it's in a file all by itself. You see how that works? All right. And what you can think of here in this we're still in the demo. Here you see that ls start, ls ident, ls sign, ls integer, and ls stop. You can think of those as being integer constants, 0, 1, 2, 3, and 4. So when you do switch on state, you can say case ls start and then case ls ident and so on. Are we good? You see how that works? And that's how you should structure it in your code as and it's separate in a separate file. Okay, into this demo. Yeah, so that public enum lex state, that's where that's how you structure that. And you can think of those as integer values. Okay, so that's a feature of the language. Actually, That's one thing that's a little bit different from the way they do it in C++. We actually used enumerated types in C++, and there they literally were integers. But in Java, they make them classes. And so there are methods that we can use on these enumerated types. And actually, I'm going to have a demo of that here later after we're done with this Q&A. Okay, these are all really good questions. Yes. So the question is, if you make a function that is like a range function, that's a good one for the util file. Yeah, that would be a good place to put it. The hex value. Okay. So the question is, would the hex value be an attribute of t integer? Now, t integer, the attribute of a t integer should be type int.
Right.
So I'm not sure if that answered your question or not.
Well, in the...
Yes. So yeah. So when you store a hex, a hex token, a hexadecimal token, its attribute should be an int. So it should be the integer value of whatever you got by parsing the hex characters. No, I thought, okay, hold on. A t integer will have an integer attribute, and t hex will have t hex will also have an integer attribute. Yeah, each one of them has their own attribute. So what happens is when you detect, look, here, let's go back to the code. Okay, here in figure 7.36, so remember, here's the outer loop, while inBuffer.input remains, so that's once per line, and then do, and then it does a token gets what? T dot what? Get token. Now, what does that return? Now, you have to imagine, you have to visualize this. What does that get token return? It returns a what? A token. So because it returns a token, then it might return a t integer, it might return a t hex, it might return a t identifier. Do you see what I mean? Regardless of what it returns, that object has within it the ability for us to access the value that we have processed. Whether it's a string value or an int value or whatever. So that's wrapped up in the object that's getting returned. That's wrapped up in the object that's getting returned. You see what we're saying? So therefore, that hex token, if we return a hex token, it has to have its own integer attribute so that we can know how to print it out. So that we'll have something to print out. We'll know the value that it has in order to print it out. Yeah, was that good? Are we good? These are all really good questions. Yeah. Yeah, that's a really good question. So the question is, for these hexadecimal constants, do we ever have to deal with these hexadecimal values? And the answer is, what we do is we convert them to integer values, to one integer value. And if we ever need to recover the hexadecimal string from that, we get it from that int. So we don't store the string of hexadecimal characters. That's a super important feature of this design. Do you see what I'm saying? So in the end, what we're going to have to do is we will have to print out the hexadecimal value, but what we will do is we will use the Java facility to print out in base 16 that int value. Do you see? So we don't want to have to store all this string. Storing strings is not the way to do it. We store integer values, and we can always display them as hexadecimal values later on in our listing. Do we output the hexadecimal value or the integer value? Yeah. Oh, yeah, so that's a good question. Now, shoot, I don't have my, wait a minute, was it the integer value?
That's what the example was.
Yeah, hold on, actually, I think I can bring it up. Okay, so here is, in the problem description, we have what? You see in that second line, we have 0x23ab. So we see here that the identifier is B7 and then hexadecimal constant, but we're just printing out the integer value for now. But what's going to happen is, so that's the answer to your question. We just printed out the integer value. But what's going to happen when we do our listing, and also when we convert to, because we're going to have to do some code generation is the last stage. When we do our program listing on the next milestone, and when we do the code generation, which will be the last milestone, we'll take that integer value and we will actually print out its hex value, but we don't store the hex intermediate. Yeah, good. That's a really good point.
We use that 913 to get back to the.
Yes, and we can use Java formatting. There's a really slick way to do that. You know how you can, you know how you have the placeholder, how you do the scan. You know how we did the printf in C? Well, or the what is it in Java? What's the string.format. Yeah, string.format. There is a feature in string.format that will allow us to say, print this out in hexadecimal. And we will let, that's one place where we will use the Java library, is on output. Yeah, that's a really good question, because everyone, there's always a huge temptation to have to store the hex values as a string, but that's expensive. And it was all we need, because it's just one integer value. We can print it out in whatever representation we want. Good questions. Yeah. It should, okay, so the question is, how do you make it so that it doesn't print out the empty token at the end of a line? Yeah. The answer is, you have to print out the empty token at the end of the line, because at the end of the line, it will detect the empty token. Are you with me? Okay, so look, in fact, here's an example. You see how it says alpha and then dot beta, and then the start of the next line, identifier equals alpha, dot command equals beta, and then what? That's because we're at the end of the first line. So you need to detect the empty token, and the empty token needs to be printed out to make sure that your program is working correctly at the end of each line.
Okay, I was confused because the assignment had like a listing of of things, and they only had empty token at the end.
Oh, you know what? That must have been an example where there was only one line.
Okay.
I'm thinking. Where did you see this code?
Assignment 14 on the online part.
Oh, on the online part?
Yeah.
Really? No, I need to correct that if that's the case. Hold on, let's look. Oh, I see why. Yes, in the problem description where we have erroneous ones, that's the exception to the rule. Syntax error. Because what happens is when we get a syntax error, we just skip the rest of the line, and we don't detect the new line. We don't detect the empty token on a syntax error.
Okay.
That's because it was a syntax error example. Oh, that was a good question. Yeah, but you see why that is. So I'm thinking, I'm not going to be up at midnight tonight to collect these. So, but the milestones. I'm very strict about having them handed in on time. So, if you want to, I'll collect them. I'm not going to be able to collect them even tomorrow morning. So I'll collect them tomorrow at noon. So if you want a little extra time, that's fine. But that's a hard deadline. Yeah, I think that's a good idea. Now, if you have something like this, like B4 plus, or maybe B4 hyphen 23, you know that after you get, once you get to this 4, and you are in the state, let's get the exact state. Okay, so like here in figure 7.53, if you scan this B4, then what state will we be in once we scan the 4? LS ident, which is a final state. Then what will happen is we'll scan the hyphen. And then, the point is, then you will detect the identifier. You'll back up the input so that the next time you'll get the hyphen in front of the 2, 3. Yeah. But your question about style, yeah, it's okay to reassign it to +1 even though it was initialized to +1. So you can see that it, yeah, that's a documentation. That's a cheap, it's one extra assignment statement, which is very cheap because they're so fast, but it documents. So the trade-off, that's a good trade-off. Yeah. Good questions, keep asking. Yes.
Are you supposed to get an empty token or no?
Yeah, so the question is, if you run the program without putting anything in the input box, should you get the empty token? And the answer is emphatically yes. Did you? Good. Yeah, because do you remember why? Do you know why? We add those two new lines, and it's for just that reason. It's so, because we needed to have an empty token so that we could go through that loop at least one time. You see, I mean, we had to have some new lines in there so that we could scan them when we go through the loop, because one of those loops was a do as opposed to a while, and the test was at the bottom. But yeah, but that means we will detect the empty token if the user puts nothing in. And that's by design. That's how we designed it that way. Yeah, good question. You know, it's really, those cases, like what happens when something is empty, those are called corner cases. And they are the ones that are the easiest. It's easy to have bugs in the corner cases, you know, like the unusual cases at the corner. I mean, you know, like at one extreme or the other. One extreme being really, really long, another extreme being empty. But anyway, yeah, so we have to be careful that it works under all circumstances like that. Okay, good question. So look, that transition from ls int 1 to ls hex 1, one of those x's is lowercase and one of those x's is uppercase. Yeah, so that's why that's not a typo. Are you with me? Because also, by the way, you guys, also in Java and C, that's the way it is. In C, you can have a lowercase or an uppercase x. Yeah. And you know how when we do bash x00, I believe it's uppercase or lowercase x is allowed there also. So yeah, so we have to allow both. I don't know if you noticed, but in the homework assignment, the previous homework assignment, I tested it with, oh, that wasn't x, that was z. One of the tests that I ran was ZZ. And some of you guys failed, some of your code failed on this one, I noticed. Because you didn't take into account that it could be uppercase as well as lowercase. Anyway. But yeah, same thing here. Are we, yeah, more? Yeah, anytime you call a function, it's usually less efficient. So if you're talking efficiency, that's kind of the general rule of thumb. Although some super optimizing compilers can actually expand the code for the function in line. So, you know, that's a good compiler. I mean, it could depend on the compiler. Yeah, but as a general rule of thumb, calling a function, because what happens when you call, because what happens when you call a function? First thing, what? What happens when you call a function? First thing, what? Push the what? Come on, a non-void function. What's the first thing? Oh, this is good review for the exam. For every exam in this class. Push the what? Storage for the return value. Then what? Not storage for the actual parameters, but push the what? Push the actual parameters. And then what? Not storage for. Push the return address, and then what? Now's your chance. Storage for the what? Local variables. We're going to do that in assembler. We're going to have to do that in our assembly code, because that's what the compiler has to generate. It has to generate statements for doing each one of those things when it translates a function. Now, why did we get off on that? Oh, because we were talking about function calls. Yeah. Okay. More questions? Yes, when you turn it in, first of all, there's a lot of people are forgetting to make sure that you include the source code. So, make sure that you, in NetBeans, that you have that feature that makes it include the source code, and then you do a clean and build. And then when you turn in the jar file packages everything up into one .jar. And then our grading script will unpack that and strip off the .code and keep the .java, and then compile the .java. But yeah, all those files all those files that are in the same package. Oh, which brings me to another point that we haven't really explained. We've just done it, and that's the Java package. Now, for those of you who've programmed in C and C++, what do you always have to have at the top of your in the top of your file if you have two different files and you want one file to be able to use the code in the other file? Hashtag what? Include. All right. Now the nice thing about this Java package does the same kind of thing. If you put all of your individual files in a package, then any file, any piece of code from one of those files can use the code from the other files in the same package. So that does the same thing. It serves the same purpose as the #include in C or C++. Is everybody clear on that? And that's why, and you'll notice all of our programs have always had a project folder, and then they've had, or in NetBeans, if you look at the project pane, we've always had the name of the project, and then the name of the package, and then the name of each file. And at the top of each one of those files, you've noticed this before, right? It says package whatever. So all those files, they all have the same package name, and that way they can all access each other. So that's the way your code should be set up. Probably should have mentioned that earlier, but better late than never. Are we good? Any more questions? All right. Well, in that case, I would like to end with one demo. Okay, so we're going to end with one demo. And this demo is called the map demo. So here it is. Let's just run this. All right, now check this out, you guys. Enter a planet. Pluto? All right. Oh, is it? Well, I think that, oh, what does it say here? What did it say? Can you read it? Pluto is far from the sun. Enumerated output. P_Pluto. Ordinal output 8. You want another planet? Jupiter? How do you spell Jupiter? Jupiter? Enter. What does it say? Jupiter is a what? A big planet. Enumerated output. Jupiter. Ordinal output 4. I wonder if it's here. I wonder if it's bigger than Texas. What do you suppose is going to happen here? Texas is not a planet. Okay? Now, does everybody see what see how that demo worked? Okay, let's go look at some code. Okay, so now the reason we're doing this demo is because for the next phase of your project, our language translator project, we are going to use a data structure in Java called a Java map. All right. Now, those of you who took the data structures, I see that not all of you have, and that's fine. But those of you who took data structures, do you remember when we did dictionaries? What's the key feature of a dictionary? A what? A key value pair. Yeah. So that's a map is just Java terminology for what is also called a dictionary. all right? And it's based on what are called key value pairs, okay? And here on this slide, oh, and by the way, this material is not in the book because it's Java specific, and I just, you know, so it's not in the book. But here it is on the slide, and we just saw the demo. And you'll have access to this code to use whenever you have to set up your maps for the next stage of your project. So here we say, oh shoot, I didn't do Mars. Should have done Mars. Oh, can you tell on this slide, how did we spell Mars? Lowercase m, lowercase a, uppercase r, uppercase s. And what did it say? And oh, I forgot to demo this feature. What did it say? Planet what? Mars. But now how's this Mars written? Uppercase m, lowercase a, lowercase r, lowercase s. Are you with me? So planet Mars is read. Enumerated output, p underscore Mars, ordinal output, 3. And then and interplanet, Texas. Texas is not a planet. Now, does everybody see how that worked? Okay, so now what we want to do, actually, I see it's about time to go. So I think what we'll do is we'll start up with this tomorrow. And by the way, don't we have an exam coming up in here? In fact, isn't it Thursday? So here's what we'll do. Tomorrow we will look at the code for this and get that under our belt, and then we will review for the exam. How's that? All right, good deal. See you tomorrow.